Gravitation. In this lesson, one of the important topic is universal law of gravitation. What is the universal law of gravitation? The word itself is very clear that universal law. This can be applied to every planet in the universe. So here I consider two planets having the masses. Simply, I'm calling it as two bodies having the masses m1 and m2. m1 and m2. And these two masses are separated by a distance d, now the gravitational force between these two bodies is F, directly proportional to product of masses of two bodies. Product of masses of two bodies means m1 and m2, m1 into m2, and inversely proportional to the square of the distance between the two massive bodies. So what is the distance between m1 and m2? That is small d. So here I consider that F is inversely proportional to d square. F is inversely proportional to d square. By combining this one and this one, these two, then you will get it as F is directly proportional to m1 m2 by d square. F is directly proportional to m1 m2 by d square. So F is directly proportional to m1 m2 by d square means what? Remove the proportionality and keep a constant term, and that constant is capital G. Capital G. That constant is capital G. So G is the universal gravitational constant. What is the value of universal gravitational constant? 6.67 into 10 power minus 11 Newton meter square per kg square. So for every physical quantity, the existence of dimensional formula. The dimensional formula of capital G is what's the value? M power minus 1, L cube, and T power minus 2. So this is a brief introduction related to the universal law of gravitation. Now, and this universal law of gravitation, once again I am taking here, F is equal to Z m1 m2 by d square. Here I consider the first point as masses are constant. I consider the first point is masses are constant. If masses are constant, anyway G also constant, masses also constant. So what is the relation between force and the distance between the two massive bodies? F is inversely proportional to d square. So F1 by F2 is equal to, reverse the term, d2 by d1 whole square. Why? Because this is in the denominator, distance is in the denominator, so fraction can be reversed. Next one. If the distance is constant, then masses are variable here. So F is proportional to m1, m2. In the first case, the masses of the two bodies are m1 and m2. In the second case, the masses of the two bodies, m1 replaced with m1 dash, m2 replaced with m2 dash. In the second case, the force is nothing but F2. Okay, now third one. F is directly proportional to, what's the value? m1 m2 by d square. F1 by F2 is equal to, in the first case, m1 m2 by d1 square. Now by F2 means the fraction can be reversed. So d2 square by m1 replaced with m1 dash, m2 replaced with m2 dash. So like that, we consider the general formulae related to the universal law of gravitation. Okay, now here once we have considered the topic universal law of gravitation, that universal law of gravitation creates or produces the weight of the body on the surface of the planet. For example, here I consider this is the planet. Now the mass of the planet is capital M. Capital M. On the surface of the mass of the planet, here we arranged a mass of the body, small m. The gravitational force, for the gravitational force, the existence of at least two bodies. At least two bodies. So at first here I consider that this is the capital M and this is the small m, two bodies. In between these two bodies, one gravitational force can be existed. That gravitational force produces the weight of the body. How the weight is having by the body, how the weight is uh, captured by the body, and that is due to the gravitational force. So according to the topic, then gravitational force is equal to weight of the body. Then with that, we will get one relation, and that is small g is equal to capital G m by r square. What is a small g? Small g is the acceleration due to gravity, and capital G is the universal gravitational constant. Universal gravitational constant. Are you getting? Now, capital M is the mass of the body, or is the radius of the planet, or is the radius of the planet. It means it is very clear that the acceleration due to gravity is independent on mass of the body. The acceleration due to gravity never depends on the mass of the body. Whatever the mass of the body, if you consider the chalk piece, or if you consider the pen, or if you consider the book, or if you consider the satellite, or if you consider anything on the surface of the planet, the acceleration due to gravity is small g only. It never depends on the mass of the body. Then it depends on one factor, that is mass of the planet on which you consider the body, on which you consider the body. So G is equal to what's the value? Capital G, capital M by R square. Getting? Now, what are the factors affects the acceleration due to gravity? It means what? By some factors, the acceleration due to gravity onto the surface can be altered. So altered means changed. Those factors are, one is altitude, the second one is depth, and third one is the latitude. At first, I consider the altitude. Altitude means what? Height. Altitude means what? Height. So from the surface of the planet, if the height of the body gradually increases from the surface of the planet, if the height of the body, the height where the positioned body can be increased, then acceleration due to gravity also increases. Acceleration due to gravity gradually decreases. Then how come we consider the formula? The general formula of acceleration due to gravity is G is equal to, what is the formula? Gm by r square. Gm by r square. So r is the radius of the planet. Here itself it is clearly visible. And h is the height of the body from the surface of the planet. Height of the body. This is the body. This is the body. Height of the body from the surface of the planet. So what is that height? H. From the center of the planet, what is the height of the body? R plus H. From the center of the planet, the height of the body is R plus H. So GH is equal to, GH means what? The acceleration due to gravity at H height. GH means what? The acceleration due to gravity at H height is equal to Gm by R plus H whole square. Now, from this formula, if you take out the r as common, then r square you will get out, and then gm by r square. Gm by r square is nothing but z by 1 plus h by r whole square. So by the binomial expansion, gh is equal to, we will get one more formula, that is g into 1 minus 2h by r. This is one formula, and this is one formula, and this is also another formula. By all these things, it is very clear that height of the body from the surface of the planet increases, the acceleration due to gravity decreases. The acceleration due to gravity decreases. So this is very important points which we remember at the time of remembering the concepts in gravitation. Okay, now the one more factor which affects the acceleration due to gravity is depth. Depth. So previously we considered that height. If you go on increasing the height, the acceleration due to gravity decreases. Now we consider the depth. Nothing but what? We are going deeper into the earth, deeper into the planet. So actual the radius of the planet is capital R. The mass of the planet is capital M. M is the mass of the planet. Okay, I consider the body at d depth. I consider the body at d depth. So this is the d. The position of the body is at p. At p. If you consider that d depth, what is the remaining distance from the center to the point? Center to the point where you kept the body is r minus d. From center of the planet to the point where you kept, that is r minus d. So here I consider that g is equal to gm by r square. So gd is equal to gm by r means what? What is the distance of the body from the center of the planet? R minus d. That only we consider here. Gm by r minus d whole square. This is one formula in this. Okay, now I'm taking the general formula of acceleration due to gravity behalf of density in the form of density. So g is equal to gm by r square. Mass is equal to density of the body into volume of the body. Volume is nothing but 4 by 3 pi r cube. Why? Because the planets are in the shape of the sphere. So 4 by 3 pi r cube. So g rho into 4 by 3 pi r cube by r square. R square and square get cancelled. Here you will get r. 4 by 3 pi rho g r. Now, if you consider the radius of the planet is r, then the acceleration due to gravity is g. It means, how come we consider that? In this, from this, I am taking another formula, g proportional to rho into r. G proportional to rho into r. It means the acceleration due to gravity is proportional to density as well as radius of the planet. G proportional to rho r. Now, here, if the r changes to r minus d, why? Because the body is at d depth. Where is the body? The body is at d depth. So, what is the center? From the center, the position of the body, r minus d. Total is r. Total is r. From the d can be removed. Then the remaining distance is r minus d. So GD is equal to acceleration due to gravity at d depth, ZD, this is the ZD, is equal to 4 by 3 pi rho G, or replace with what? R minus D. So if you consider by using these two formulae, GD is equal to, what is the formula? G into 1 minus D by R. This is another formula in this concept. GD is equal to G into 1 minus D by R. Now, with this also, it's very clear that if go on increasing the depth of the body, the acceleration due to gravity decreases. The acceleration due to gravity decreases. It means, once again, recollect the points. You go on increasing the altitude. Altitude means what? Height. Height of the body from the surface of the planet. Height of the body from surface of the planet increases, the acceleration due to gravity decreases. In the same way, if the depth of the body increases, the acceleration due to gravity decreases again, decreases. Go on increasing the height, go on increasing the depth, the gravity decreases. That is the concept. And another one is latitude. Another factor which influences the acceleration due to gravity is latitude. So in this case, at phi latitude, what is the acceleration due to gravity? G phi is equal to z minus r omega square cos square phi. G phi is equal to what? G minus r omega square cos square phi. So at the equator, if you consider the equator, you know that equator, what is the phi value? 0 degree. Then if you apply phi equal to 0, cos 0 equal to what? 1. So at the equator, the acceleration due to gravity is GE, that is equal to Z minus cos phi equal to 1. So G minus R omega square. G minus R omega square. From the acceleration due to gravity, you are subtracting, you are reducing another value. So the resultant value is less than G. Here it is very clear that GE less than G. So again, at poles, phi is equal to 90 degree. Cos 90, 0. 0 into anything equal to 0. So Gp, nothing but gravity at poles, Z. It means here, if you just observe, at the equator, the acceleration due to gravity is less than at the equator, the acceleration due to gravity is less than the actual value of the acceleration due to gravity on the surface of the planet. G means acceleration due to gravity on the surface of the planet. What is its value? 9.8 meter per second square or 10 meter per second square. So at the equator, that value is less than 9.8, and whereas exactly equal to Z at poles. At poles, it means if from equator to poles, if you go on continuously, the acceleration due to gravity also gradually increases from equator to poles. So thereby here I am taking one thing, that is weight of the body. If you consider a body and by using the balance, just weighing that body, thereby you will get one weight. Go on increasing, you are go on taking the body from equator to poles, the weight also gradually increases. Why? Because weight is nothing but what? Mass into acceleration due to gravity. Mass into acceleration due to gravity. Weight is dependent on, weight depends on acceleration due to gravity. If the gravity increases, weight of the body also increases. So from equator to poles, if you go on taking the body continuously, the weight of the body also gradually increases. Okay, now so here, based on those, I'm taking some problems, and first problem is the gravitational force between the two bodies is 6.67 into 10 power minus 7 Newton. So F is equal to what's the value? 6.67 into 10 power minus 7 Newton. When the distance between their centers is 10 meter, D is equal to what's the value? 10 meters. If the mass of the first body is 800 kg, in the problem given that mass of the first body m1 is equal to 800 kg, and we need to calculate what? M2. We need to calculate the M2. Now take the formula. F is equal to G m1 m2 by D square. Okay, so in this problem what we need to calculate? Mass of the second body. For the gravitational force, there existence of two bodies. One body mass is given in the problem, 800 kg. We need to calculate the mass of the second body. For doing the problems, at first we need to know what we need to calculate. First point. Second point is, by reading the problem itself, we need to analyze the problem belongs to which lesson, which topic. After that, what is the subtopic? Once you got the idea of topic, immediately you can memorize the formulae in that particular topic. Then only you will get the confidence to do the numerical. So keep on practice the formulae, keep on read out the formulae, keep on moving the concept CDF, concepts definition as well as the formulae, and thereby you will get one confident, okay, I know this topic, I know this formula, so I can do this problem. Like that confident you will get. Okay, now so F is equal to 6.67 into 10 power minus 7 is equal to Z 6.67 into 10 power minus 11. M1 is nothing but 800 kg and M2 is like this by D is nothing but what's the value? 10, distance between the two planets, D square. 6.67 get cancelled. Minus 7 cancel, remains minus 4, and two zeros cancel. 1 is equal to 10 power minus 4 into 8, M2. Now M2 is equal to 1 by 8 into 10 power minus 4, and that is equal to 10 power 4 by 8. 10 power 4 by 8. So if you calculate this, then you will get the value is mass of the second body is 1250 kg. 1250 kg. Another problem. If the distance between the sun and the earth is increased to 3 times, In the problem, it is clearly mentioned that the distance between the sun and the earth is increased to 3 times. That's why here I consider that initial distance is d, initial separation between the two bodies, the two planets, sun and the earth, is d, and then afterwards the distance increases. If the distance increases, it is very clearly known that the gravitational force is inversely proportional to the square of the distance. It means once inversely proportional means what? If distance increases, the gravitational force decreases. That is the meaning of that. Okay, now take the formula. F is inversely proportional to d square. F1 by F2 is equal to d2 by d1 whole square. Then substitute the values, and then you will get the value as F2 is equal to, what's the value? F by 9. It should be lesser than the initial force, where you consider the separation is small d. Okay, so when you compare to that value, and this value must be lesser. What is the value when the separation is d? That is F only. Now when the separation is 3d, then what about the value? F2 is equal to F by 9. It means distance increases, gravitational force decreases. Now come to the another thing. Here I consider one equilateral triangle. Equilateral triangle, at 3 vertices of the equilateral triangle, identical masses are arranged. M, M, M. Identical masses are arranged. Here I need to calculate the net gravitational force. The net gravitational force or resultant gravitational force on any one of the body. On any one of the body. Among the 3 bodies, take any one. So I consider this is the body. This one. And one more thing you need to know, the gravitational force is always attractive force. Always attractive. There is no repulsive force. Only attractive force. So wherever you need to calculate the gravitational force, wherever you need to calculate the gravitational force, there you need to consider a body, the existence of a body, right? So where you need to calculate the gravitational force, at that point, if any body is present, on that body, the gravitational force can be experienced. That body gravitational force can be experienced. It means what? For example, here I consider the mass of the body is m. This is the victim. Why? Because this experiences the gravitational force from remaining bodies. What are the remaining bodies? Here one body is present and here one body is present. With this, gravitational force can be experienced by this body. With this also, the gravitational force experienced by this body. So this body attracts this one, This only moves. Where you need to calculate the gravitational force, that mass only moves. Remember this. Where you need to calculate the gravitational force, that mass only moves. That's why I'm using the word that is the victim. Okay, now this is only moves towards this, and again this only moves towards this. Thereby the direction is F1 bar towards this direction, F2 bar, the moment of this mass is towards this direction, F2 bar. The resultant of F1 bar and F2 bar is F net, net gravitational force. That can be calculated by using the parallelogram law of vectors, root over F1 square plus F2 square plus 2F1 F2 cos theta, root over P square plus Q square plus 2PQ cos theta, well-known formula in the vectors. Okay, now, so here at first we need to calculate the magnitude of the forces, F1 and F2. So F1 is equal to what? F2. Why? Because masses are same and the separation between these two masses also same. Here also masses same and separation also same. And that's why F1 is equal to F2. That is equal to G M1 M2. M1 is M, M2 also M, M into M, M square by what is the distance? What is the distance? A square. Then F net is equal to root over F1 square plus F2 square plus 2 F1 F2 cos 60. Cos 60 is nothing but 1 by 2. 2 get cancelled. Root over F1 square plus F1 square plus F1 square. That is 3F1 square. Then you will get it as root 3F1. Root 3F1. Now F net is equal to root 3F1. What is the F1? What is the F1 here? See this, gm square by a square. Root 3 into gm square by a square. Like this, we can solve this problem. Another problem. Two spheres means two planets are in contact like this, having the center's separation is d. This is one center, this is another center. Center separation is d. The mass of one planet is m1, the mass of another planet is m2. Thereby F is equal to what's the value? Z m1 m2 by d square. As you know that mass is equal to what? Density into volume. Rho. Rho is the density. Density into volume. Volume is nothing but what? Volume of the sphere. 4 by 3 pi r cube. So here what is the radius? This is the radius. Distance is d, two centers. Then what about the radius? Exactly half. D by 2. That's why F proportional to mass. Anyway, rho is constant. Forget about that. 4 by 3 pi. R is d by 2 whole cube. Just now I said that R is equal to what's the value? D by 2. Exactly half, no? D by 2. So F proportional to 4 by 3 pi. 4 by 3 pi anyway constant. dq by 8. dq by 8 by d square. Anyway, the separation is d. Now 8 and 8 also constants. Forget about that. F proportional to d power 6 by d square. And that is nothing but what's the relation in this case? The force is directly proportional to d power 4. Force is directly proportional to d power 4. Another problem. Same, previously we considered that one triangle. Here also I consider one triangle, equilateral triangle. And at the three vertices of the equilateral triangle, we arranged three identical masses, m, m, m. We need to calculate what is the net gravitational force at the centroid. At the centroid, this is the centroid. At the centroid, we kept a mass. Why? Because if you want to calculate the gravitational force, there must be existence of mass. So at the centroid, I kept again identical mass, that is m. M. Okay, what is the question here? I need to calculate the net gravitational force at the centroid. At the centroid. Okay. Now, so I considered from each vertex, I considered like this: one line, another line, and another line. I said to you where you need to calculate the gravitational force that only moves. That mass only moves. So I need to calculate at the centroid. I need to calculate the gravitational force at the centroid. So at the centroid, whatever the mass is present, that only moves in all directions. So first possibility, this m at the centroid, whatever the mass is present, that mass moves towards this mass, and again tries to move towards this side, and again tries to move towards this side. So F1 bar, F2 bar, F3 bar. Each and every mass at the vertex try to pull the body towards it. So here F1 bar, F2 bar and F3 bar. At the centroid, the angle is 360 degree. So the angle between F2 bar and F3 bar is 120 degree. 120 degree. And again, this is 120 in between F1 bar and F3 bar. And again, F1 bar and F2 bar also 120 degree. And total is 360 degree. Here I required only this F2 bar and F3 bar. And that's why I considered 120 degree. Now, for calculating that, at first we need to calculate the height of the triangle. Height of the triangle. So in the equilateral triangle, having the height formula is root 3a by 2. A is the side of the triangle. Root 3a by 2. In the equilateral triangle, the height divides, the centroid divides the height in the ratio of 2:1. The centroid is divides the height in the 2:1 ratio. I required from the vertex to the centroid. How many parts here? How many parts? Observe, 2. How many parts here? 2. So D is equal to, total distance is D. It means I considered what the distance between the vertex to the centroid is D. Vertex to the centroid is D. So that's why D is equal to, H is root 3a by 2. In that I consider 2 points, nothing but 2 parts. What about the total? 2 plus 1, 3. Among the 3 parts, I required only 2 parts, and that's why 2 by 3. Now what happened? The distance D is equal to a by root 3. D is equal to, what's the value, ma? A by root 3. Now F1 is equal to masses same, separation same. Masses same, separation is D. F2 equal to masses same and separation again D, from vertex to centroid anywhere is constant. Again masses are same and distance is same. So F1 is equal to F2 is equal to F3. Gm square by D square. Now in the vectors we have one formula. Magnitudes of two vectors are equal and the angle between the two vectors is 120 degree. Then the resultant of those two vectors is equal to either of the magnitude of the two vectors. Modulus of A bar is equal to modulus of B bar and theta is equal to 120 degree. Then the resultant of A bar and B bar is C bar. The magnitude of C bar is C. Then that C is equal to either A or B. Any one magnitude it should be considered. In the same way, F2 bar and F3 bar both are equal. Magnitudes are equal here. So the resultant is F4. By applying the parallelogram law of vectors, we will get that value is either F2 or F3. We can save the time in the exam by knowing the concepts. Otherwise, doing the resultant, doing the parallelogram law of vectors, entire calculation and the substitutions and all these things, time waste in the exam. So sometimes to solve the problem, we required the analysis of all the topics which you learned. Okay. So F net is equal to F net. This is F4. Already we calculated. F net is equal to F1 and F4. Both are in the opposite direction. So F1 difference F4. Then F net is equal to what? F1 difference. F4 is equal to F2. So F1 difference F2. What about F2? F1 is equal to F2. So both the magnitudes are same and acting in the opposite direction. F4 replaced with F2. Both are acting in the opposite direction. And that's why here that value is equal to 0. So net force at the centroid is 0. Net force at the centroid is 0. F4 replaced with F2. So F1 magnitude is same, F2 magnitude is same. Both the magnitudes are same, both are same values. In the same values, if you do the subtraction, what is the value? 0. So that's why at the centroid, the net force is 0 at this point. Another problem. Listen. Here I consider a square. At the four corners of the square, I'm taking identical masses m, 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 and m. Now, I need to calculate the net gravitation force on any one of the corner. On any one of the corner. Previously, we considered the triangle. Now I consider the square. On any one of the corner, I need to calculate the net gravitational force. So I consider this is the corner. At this corner, M is present. This is the victim. This only moves in all directions. So this mass attracts this one, that is F2 bar, and this mass again attracted by this one, F1 bar, and again this mass attracted towards this, that is F3 bar. F3 bar. So resultant of F1 bar and F2 bar, F1 bar and F2 bar is F4 bar. Replace F1 and F2 with F4. That F4 also in the same direction as F3. So it's very clear that masses are same, distance is same. So F1 is equal to F2, and that is equal to Gm square by A square. Then for calculating F3, we require this distance. This is the diagonal of the square. Why? Because F3 is along the diagonal. F3 is along the diagonal. So diagonal in the square is, this is A, and this is also A side. Diagonal is root 2A. That's why G m1 m2. M1 is m, m2 is also m. M square by distance is root 2A whole square. That is G m square by 2A square. Now apply the parallelogram law of vectors. F4 is equal to, we need to calculate the F4. F4 is equal to root over F1 square plus F2 square. Why? Because the angle between F1 bar and F2 bar is 90 degree. In the parallelogram law of vectors, P1 square, P square plus Q square plus 2PQ cos theta, cos 90 equal to 0. So no need to write the third term. And directly here I consider only two terms. One is P square, the other one is the Q square. Here P is equal to F1, Q is equal to F2 root over F1 square plus F2 square. Okay, now F4 is equal to root over F1 square plus F2. F2 also equal to here F1. So replace F2 with F1. Then root over 2 F1 square, 2 times repeated. Again, if you take the calculation, then you will get root 2 F1 if you remove the root. Now F net is equal to net force on this mass. Then F3 is one direction, F4 also in the same direction. And that's why same direction, nothing but F3 plus F4 need to add. F3 is equal to Gm square by 2A square. F4 is equal to root 2 F1. Then F1 is equal to what's the value? Gm square by A square. If you substitute those values in this F3 plus F4, F3 is Gm square by 2A square plus F4 is nothing but root 2 F1. F1 is equal to Gm square by A square. Then Gm square by A square is present in this term as well as in this term. So take the Gm square by A square as common, and the remaining part is Gm square by A square. If you take the common, and then you will get it as in this 1 by 2 left, in this root 2 left. So 1 by 2 plus root 2. And this is the net gravitational force on any one corner in case of the square, if identical masses are present. Okay,